It's the morning of January 10th, 2026. In the quiet stillness of the cosmos, something unexpected has been unfolding. We've become accustomed to the celestial visitors that pass through our solar system, asteroids and comets that zip by, often unnoticed, leaving little trace behind. But one object has captured the attention of astronomers, scientists and sky watchers alike. 3 Atlas, an interstellar visitor from a distant star system, making its way through our corner of the galaxy. Unlike the typical wanderers of our solar neighbourhood, this visitor behaves in ways that defy the established norms. While most comets follow predictable paths, shedding gas and dust as they near the Sun, 3I Atlas has shown something entirely different. A comet is meant to be a chaotic, unpredictable entity, a dirty snowball shedding dust and gas as it heats up. But 3 Atlas has remained oddly structured, even as it makes its perilous journey through the solar system. The first signs of this anomaly came in November 2025 when Paul Craigs, an amateur astronomer, took a photograph that would change everything. With a simple backyard telescope, Craigs managed to capture an image of 3I Atlas that was unlike anything the professional telescopes had shown. What appeared in his photograph was no typical comet, no fuzzy blur of dust and ice. Instead, there was a sharp, defined object with a brilliant white core surrounded by an eerie blue glow, almost as if it was surrounded by an energy field. The image was clear, structured, and almost artificial in its appearance. This image sent shockwaves through the scientific community. Comets, by their very nature, are messy, chaotic. They break apart, they fragment, and they release gas and dust in unpredictable patterns as they approach the Sun. What Craigs captured was the exact opposite. The object appeared to be controlled, deliberate, and incredibly structured. Nothing like the blurring, fragmented masses that we've come to expect from comets. When the image was shared online, many dismissed it as overprocessed, a glitch, or an artifact from the telescope's equipment. But then, other amateur astronomers, using similar equipment, began capturing images that showed similar features: sharp edges, clear structure, and a strange glow. The excitement began to build. Could it be? Could 3 Atlas be something entirely different from what we'd been told? Could it be that this object was not a comet at all? To better understand what was going on, astronomers began to compare this new data with what the most advanced telescopes had captured. The professional images from observatories like Hubble and the James Webb Space Telescope showed 3I Atlas as a blurry, indistinct object, essentially the expected comet, with a coma and a tail of gas and dust. But when compared to Craig's image, the professional data seemed incomplete, or perhaps even misleading. The new amateur images suggested something far more structured and organised, something that should have been impossible for a natural comet. So what was going on here? How could a modest backyard telescope capture something that professional instruments had missed, or perhaps overlooked? The answer, of course, isn't clear, but the fact that an amateur astronomer with a relatively inexpensive telescope managed to resolve details that billion-dollar instruments couldn't seems to point to something significant. At this point, the official story about 3I Atlas was that it was just another comet, a wandering chunk of ice and rock from another star system, and yet there was something about this object that didn't fit the script. When it was first detected on July 1st, 2025 by the Atlas survey, it appeared to be just another comet, a faint smudge of light moving against the backdrop of distant stars. But as astronomers began calculating its trajectory, something extraordinary became clear. This object wasn't just another comet. It was on a hyperbolic trajectory, which meant it wasn't bound to the Sun's gravity. It was simply passing through our solar system on its way to parts unknown. This information set off a flurry of activity within the scientific community. With 3 Atlas moving at a speed too great for our Sun to capture it, the object quickly became the subject of intense observation. From the moment it was discovered, telescopes from all over the world, from Chile to Hawaii, began tracking its movements, gathering data on its size, shape, and composition. Even spacecraft like the Solar Orbiter and Stereo A turned their attention to this mysterious object, trying to capture as much data as possible before it left the solar system for good. By late October 2025, as 3I Atlas approached its closest point to the Sun, astronomers were eagerly awaiting what would happen next. Comets are known to behave in specific ways when they approach a star. They heat up, shedding gas and dust as their ice evaporates under the sun's radiation. But 3I Atlas was acting differently. Despite its close approach, it wasn't showing the expected signs of distress. Instead, it held its course with eerie precision. There were no chaotic outbursts or erratic behavior. Instead, it was almost like the object was responding to the sun, adjusting its course and behavior as it passed through our star system. The usual comet chaos had been replaced with something far more deliberate, something controlled. This is where our story begins, on the brink of a new discovery, with 3I Atlas defying our expectations and forcing us to ask the unasked questions. What is this object really? And what does its behavior tell us about the objects travelling through the universe? Is 3I Atlas truly a comet, or is it something else entirely? Stay tuned, because the data we're about to uncover will change how we think about comets, interstellar visitors, and perhaps even what is possible in the universe. The year was 2025, and 3 Atlas had already begun its journey into the history books. Discovered by the Atlas survey on July 1st, 2025, this object from interstellar space, which came speeding toward our solar system, was only the third of its kind to be officially documented. It seemed like a routine discovery at first, just another interstellar object making its brief pass through our cosmic neighbourhood. But as the months went by, and as the data began to come in, something about 3I Atlas began to stand out. Something was wrong. When it reached its closest approach to the Sun in late October 2025, scientists expected the usual. Comets, upon nearing a star, will heat up and begin releasing gas and dust in unpredictable bursts. The Sun's radiation is typically enough to cause rapid sublimation, solid ice turning into gas, which leads to the formation of a coma, the cloud of gas and dust that we often associate with comets. This process is messy, chaotic, and, as many astronomers know, predictable. The core of the comet would begin to fragment, the cloud would get larger, and the object would gradually dissipate into the solar wind, the usual comet behavior. But what scientists observed with 3I Atlas was anything but typical. The first signs that something was off came from multiple global observatories. While other comets had shown their tails spewing out dust and gases as they approached the Sun, 3I Atlas remained strikingly stable. In fact, before its perihelion, its closest approach to the Sun, it showed no significant changes in brightness or activity. This was unlike any comet that had ever been studied. It didn't fragment, it didn't collapse, it didn't break apart into the dust and debris we expect. Instead, it held its course, almost with uncanny precision, moving steadily through space. It was behaving, or rather, it appeared to be responding, adjusting itself with a kind of intentionality that was unheard of in the realm of comet physics. To truly understand the magnitude of what was happening, let's pause and reflect on how comets typically behave. When a comet is near the Sun, the heat causes sublimation. Volatiles like water and carbon dioxide vaporize, and this releases the dust and gas that form the coma. The tail, which always points away from the Sun, is the result of this interaction. But with 3I Atlas, things were different. Observations from instruments like the Solar and Heliospheric Observatory SOHO showed a startling lack of the usual symptoms of cometary activity. No chaotic outbursts, no large debris. Just a steady, almost deliberate course through space. Even as 3I Atlas approached perihelion, the Sun's intense radiation should have caused it to release volatiles in rapid succession. Instead, something extraordinary happened. Just before reaching the Sun's closest point, the object brightened unexpectedly, a phenomenon that lasted only minutes but was recorded by several observatories. This spike in brightness was not the gradual expected increase caused by sublimation. Instead, it was sudden, sharp, and distinct. The object seemed to reflect a light, almost as though it were a mirror rather than a dusty ball of ice and rock. For those observing the event in real time, it was a moment of awe, quickly followed by confusion. How could this be happening? How could an object this close to the Sun, which should have been in the midst of disintegrating, actually appear to brighten? Almost as if it were reflecting sunlight, not scattering dust and gas in its wake. As the data rolled in from multiple observatories, things began to look even stranger. The professional images from NASA's Hubble Space Telescope and other major observatories showed 3I Atlas as an indistinct, blurred object, surrounded by a coma of gas and dust, what we typically expect to see in a comet. But the amateur images, captured by individuals using much smaller consumer-grade telescopes, told a different story. These images showed something far more defined. The core of the object was bright white, with a clear, almost structured glow surrounding it. Unlike the chaotic, fragmented images typical of comets, this one appeared to have a smooth, engineered look. This led to an important question. Were we looking at a comet, or was this something else entirely? Some scientists at first dismissed the idea that 3I Atlas was anything other than a comet. They pointed to the official images and the fact that, according to traditional cometary physics, the object seemed to be behaving as expected. The coma and tail were present, albeit subtle, and the sublimation of gases from its surface made sense. But others, who had observed the object through smaller, more affordable telescopes, started to suggest something different. Was 3I Atlas truly just another comet, or was it something more advanced, perhaps a probe, or a phenomenon that science could not yet explain? At the heart of this mystery was one critical observation. 3I Atlas seemed to be responding, almost interacting with the Sun, rather than simply reacting like a typical comet. The anomalies didn't stop there. As the object passed closest to the Sun, data from multiple instruments revealed that the motion of 3I Atlas shifted ever so slightly. It wasn't enough to completely defy its predicted path, but it was enough to catch the attention of astronomers. The trajectory deviation suggested that something unusual was occurring. Was it the Sun's intense radiation, a strange outgassing event, or was 3I Atlas adjusting its course intentionally? The plot thickened as the data piled up, revealing more contradictions with what we knew about comets. This wasn't just a celestial body passing through our solar system. It was behaving in a way that suggested intelligence or purpose, something that couldn't be easily dismissed by the scientific community. As the mystery deepened, scientists began to ask, what if this wasn't a comet at all? What if 3I Atlas was something much more complex, something that defied the conventional rules of cometary behaviour? The scientific community had no clear answer, but one thing was certain. 3I Atlas was no ordinary visitor. It was a cosmic anomaly that demanded our full attention. The question now remains, what exactly are we witnessing with 3I Atlas? And as the object continues its journey through our solar system, we must confront the possibility that it may hold secrets that challenge everything we know about the cosmos. As 3I Atlas continued its journey through our solar system, astronomers were watching closely. The anticipation had been building for months, ever since the discovery of this interstellar object. With its hyperbolic trajectory, meaning it was just passing through our solar system and wasn't bound to the Sun's gravity, 3I Atlas was already behaving in ways that had piqued the interest of the scientific community. But when it reached its closest approach to the Sun, its behaviour became even more perplexing. The date was October 29, 2025, and 3I Atlas was at its perihelion, the point at which it would be closest to the Sun. At this distance of about 1.4 astronomical units, just inside the orbit of Mars, this object should have been facing the full fury of the Sun's radiation. Comets, when they pass close to a star, experience intense solar heating that causes them to shed gas and dust in dramatic bursts. As the Sun's rays heat the icy nucleus, the volatiles sublimate and create a coma, an envelope of gas and dust surrounding the core. This process is chaotic, messy, and well understood. But 3I Atlas didn't follow the script. The Sun, with its overwhelming radiation, should have triggered rapid sublimation on the surface of 3I Atlas. The object should have brightened gradually as it neared perihelion, with its ice turning into gas and forming a tail of dust and gas streaming away from the Sun. However, as the object approached the Sun, it remained eerily steady. No chaotic outbursts, no massive jets of gas or dust. The nucleus of the comet was still intact, and there was no sign of the expected breakdown of material. Instead, the object held its trajectory with almost mechanical precision. This lack of typical cometary behaviour was the first major sign that 3I Atlas might not be what it appeared. Professional telescopes, including NASA's Hubble and the European Space Agency's Solar Orbiter, were tracking the object, but the data didn't match the predictions. When 3I Atlas passed closest to the Sun, a surprising spike in brightness occurred, a sudden burst that lasted only a few minutes but was detected by multiple observatories. This was not the gradual increase in brightness that is expected from sublimation. Instead, the object appeared to reflect sunlight in a way that no comet should. To make matters even more puzzling, the data suggested that the object's brightness did not follow the typical curve of a comet. Instead of gradually increasing in brightness as the sun's radiation heated it up, 3 Atlas suddenly brightened, almost as if it were actively reflecting sunlight. This sudden increase in brightness was followed by a rapid stabilization. For a comet, this wasn't just unusual, it was completely unprecedented. No known comet has ever shown this kind of behavior before. It was almost as if 3I Atlas had been reflecting sunlight, like a mirror, rather than scattering light as most comets do. At this point, the scientific community had no clear answers. Was this an anomaly, a glitch in the data, or was something far stranger happening? The official narrative was that 3I Atlas was a comet, an interstellar traveller composed of ice, dust, and rock. But what the observations were showing didn't quite fit. It didn't align with any known comet behaviour, and the sudden brightness spike raised more questions than it answered. While the mainstream science community continued to process the data and make sense of it, there were those who began to entertain a more unconventional hypothesis. What if 3I Atlas wasn't just a comet? What if it was something far more complex? Some began to wonder if the object was intentionally designed to behave the way it did. Could it be that 3I Atlas was a probe, or something engineered with a purpose far beyond what we can comprehend? As the sun's light continued to bathe 3 Atlas in its intense rays, something remarkable began to unfold. By November 2025, as the object moved past perihelion, the closest point to the Sun, astronomers were still reeling from the unexpected observations. Most comets, after their closest encounter with the Sun, begin to fade into the cosmic distance, their tails dissipating as the volatile gases and ices evaporate. But 3 Atlas was different. Instead of dimming, it seemed to amplify its activity. What scientists initially thought was an anomaly became a signature trait of this mysterious object. 3I Atlas wasn't just a comet. It was exhibiting behavior that defied everything we thought we knew about how comets operate. The jets that erupted from its nucleus were not only active but appeared to be aligned with strange precision. These weren't the random bursts of gas and dust we typically see with comets. They were organized and focused, shooting from specific points on the object's surface, as though they were purposefully directed. But that wasn't the only unusual feature that 3I Atlas displayed. As its coma began to expand and the jets continued their strange eruption, something even stranger appeared. A phenomenon never before seen in any cometary activity, an anti-tail. Instead of a single tail of dust and gas streaming away from the Sun, 3I Atlas seemed to be ejecting material toward the Sun, as if to defy the very laws of physics that govern comet behaviour. The anti-tail was a feature that initially puzzled astronomers. Comets traditionally have tails that always point away from the Sun, driven by solar radiation pressure and the solar wind. But the anti-tail, visible from multiple observatories, pointed in the opposite direction, toward the Sun itself. Normally, this would be an optical illusion created by the orientation of dust and debris, but the anti-tail in 3I Atlas remained visible across different viewing angles, suggesting that something far more deliberate was happening. This discovery pushed the boundaries of comet science, forcing scientists to confront the possibility that 3I Atlas was not behaving in a natural way. The physics of cometary activity were being bent by this object. It wasn't just responding to the Sun's radiation in the expected chaotic way. It was actively engaging with the Sun, with a level of control that no natural object had ever displayed. The shape and orientation of the jets were another anomaly. These jets, instead of being random or scattered, seemed carefully structured. Their alignment suggested something else was at play, something that was directing them in ways that didn't fit with the traditional models of cometary outgassing. The gas and dust weren't just being ejected as a reaction to solar heating. It seemed as though the object was consciously releasing material in specific directions and with incredible consistency. What could be causing this? Was it merely an extreme case of natural physics, pushing the limits of what we understand about comets? Or was it something more, something that wasn't entirely natural? This question began to haunt scientists as they examined the data, and when the idea of the anti-tail came into play, it became clear that 3i Atlas was exhibiting behaviour far beyond any comet's capabilities. To make matters even more perplexing, the energy required to produce such consistent, powerful jets seemed to be far beyond what the Sun alone could provide. Comets rely on the Sun's energy to fuel their outgassing, but the amount of energy 3i Atlas was emitting didn't match up with the solar radiation it was receiving. The object was outputting more energy than it should have been able to based on the amount of sunlight it was exposed to. This was a glaring red flag, signalling that something else might be powering these jets, something that was not purely solar. There were theories, of course. Some suggested that 3i Atlas might be using a form of solar sail technology, absorbing the Sun's radiation and using it for propulsion. This theory, though speculative, seemed to fit the data. Solar sails, in theory, can convert sunlight into thrust by reflecting light off a large, thin surface. Could 3i Atlas be a cosmic vessel that was harvesting the Sun's energy, using it to propel itself through the solar system? This idea was nothing short of revolutionary. It would mean that 3i Atlas wasn't just an interstellar object, it was possibly a machine, or something engineered, designed to interact with stars and use their energy. Of course, not all scientists were ready to jump to such conclusions. The official line remained that 3i Atlas was a comet, albeit an unusual one. But the anomalies were mounting. The precise jets, the anti-tail, the energy output, all of these things defied traditional cometry models, and the more data that came in, the more it became clear that 3i Atlas was pushing the boundaries of what we thought was possible. As the days passed, and the object moved further away from the Sun, the strange features persisted. The anti-tail remained visible, and the jets continued to emit material in highly structured patterns. The object was now heading back toward the outer reaches of the solar system, but the mysteries surrounding it were only deepening. Scientists could no longer simply call it a comet. They were forced to ask the question, could 3i Atlas be something far more sophisticated, something beyond our current understanding? With each new observation, the enigma of 3i Atlas grew. The data didn't add up. The behaviour of the object didn't fit. And for the first time in modern astronomy, we were forced to confront the idea that the rules of cometry science might not be enough to explain what we were seeing. As the investigation continued, one thing became certain. 3. Atlas was not just an object in space. It was a key to unlocking a deeper mystery, one that might change the way we think about the cosmos. One of the most intriguing aspects of 3i Atlas was its ability to maintain its trajectory. For comets, when they approach a star, they typically experience a gravitational perturbation or heating that causes them to break apart or fragment. The resulting debris is often scattered throughout space, and the coma formed by the outgassing can be massive. But 3i Atlas seemed to hold its structure intact despite the Sun's radiation. There was no disintegration, no fragmentation, no dust cloud of debris forming around it. In fact, it seemed almost unaffected by the Sun's energy. And yet, the brightness spike and the sudden acceleration in motion, things that no comet had ever shown before, demanded an explanation. As the data continued to come in, astronomers began to realize that 3i Atlas was not acting like any comet they had ever studied. The behavior wasn't consistent with any known model of cometry physics. The object wasn't behaving chaotically or unpredictably as comets tend to do when they pass close to a star. Instead, it seemed to be acting with deliberate precision. Even more unnerving, the object appeared to be responding to the Sun's energy in a way that defied all expectations. The concept of an object interacting with solar radiation in such a precise manner was not something that had ever been observed before. The idea that a comet, or any object, could actively harness energy from a star, absorb it, and use it for its own purposes seemed almost fantastical. Could it be that 3i Atlas wasn't just a cosmic wanderer, but something more complex, something engineered to do exactly what it was doing? This chapter of the story is just the beginning. The closer we get to the truth behind 3i Atlas, the more we realize that this object is far more than just a comet. It's challenging everything we thought we knew about comets and interstellar objects. It's forcing us to rethink what we know about the laws of physics and the nature of objects that travel through space. And as the data continues to roll in, one thing is certain. 3i Atlas is an enigma, a cosmic mystery that we are only beginning to unravel.